Hi, I'm Senthil Nathan Subramanian, a senior staff architect at Panasonic Automotive, a global supplier for automotive and mobility technologies to the world's leading OEMs. Currently, there is a significant shift in the automotive industry as we move away from hardware-centric designs to software-driven architectures, making vehicles essentially a data centers on wheels. This evolution brings unique challenges as suppliers work to adapt new operating systems and software designs. This industry-wide shift is why initiatives like SOAFEE are crucial, defining the standards that enable a common cloud-native framework for building SDV platforms like VirtualSkipGen or vSkipGen. To solve this, I am proud to demonstrate Panasonic Automotive's VirtualSkipGen or vSkipGen, a cloud-based platform tailored for automotive software developers and testers. This innovative solution enables users to deploy individual virtual machines in the cloud, supporting operating systems such as Yocto Linux, automotive-grade Linux, and Android Automotive. VirtualSkipGen provides a VirtIO-first environment and an intuitive web interface with advanced support for GPU, audio, CAN, and video, including tools for multi-display setups. These capabilities empower developers to build and test a wide range of automotive applications, such as next-generation infotainment platforms, head-up displays, user interfaces, instrument clusters, camera display solutions, surround view systems, and rear seat entertainment systems. Building upon the SOAFEE initiative foundation, vSkipGen delivers a practical, cloud-native, and virtualized automotive development environment, making it possible for teams to accelerate innovation, streamline workflows, and bring sophisticated in-vehicle experiences to life. So how does it work? At the heart of Panasonic Automotive's VirtualSkipGen is a powerful cloud-native virtualization stack built on Linux KVM and designed to run on AWS with the support for Google Cloud coming soon. It uses a purpose-built virtual machine manager that acts like a lightweight hypervisor, enabling entire operating systems to run virtually with a near-native performance. This environment employs VirtIO-based device virtualization, providing virtualized access to peripherals like a CAN, GNSS, cameras, videos, and audio, along with core interfaces such as networking and storage. These virtual devices are not just static emulations. They can be integrated with automotive simulators like a Carla to create a sophisticated software-in-the-loop environment. vSkipGen also supports advanced graphics and audio acceleration, streaming the display and sound output directly through WebRTC so the developers can interact with the system through any modern browser. Panasonic Automotive vSkipGen aligns closely with the principles of the SOAFEE architecture by enabling service-oriented, cloud-native development for automotive systems. At its core, vSkipGen uses VirtIO-based virtualization and maintains ARM binary parity, ensuring that code developers build and test in the cloud runs at bit-level equivalents to the code deployed on actual vehicles. This dramatically simplifies the development cycle by eliminating cross-compilation and hardware dependencies. vSkipGen's containerized design, support for heterogeneous operating system, and integration with simulations tool create a seamless, scalable software-in-the-loop environment, delivering not only simulation capabilities, but real, production-ready code, exactly as SOAFEE envisions for accelerating software-defined vehicle development.
Hi, I'm Vladimir Goloborodov, a senior staff engineer and software architect at Panasonic Automotive. Now that we have covered how our innovative vSkipGen solution works, I'd like to highlight its unique features and capabilities. SkipGen allows running multiple virtual machines with Android Automotive operating system Cuttlefish throughout, version 13 and later, Linux-based systems such as Yocto Linux builds, or the recent versions of automotive-grade Linux, AGL. On all guest virtual machines, vSkipGen supports a variety of VirtIO devices, including storage, GPU, sound sensors, cameras, and wireless communications such as Bluetooth and Wi-Fi. That enables global development and testing collaboration by significantly reducing hardware and physical hardware build requirements, while also streamlining Android version upgrades, compressing integration timelines from several months to just a few days. Virtualization of peripheral devices in vSkipGen is based on the VirtIO standard, which is widely adopted and leveraged in modern automotive software designs, and it is being used in the SOAFEE architecture. This means that both individual software components and whole virtual machines developed and tested on vSkipGen can run on the target edge devices, such as head units and high-performance compute modules, without the need to modify or rebuild them in any way. Let's see vSkipGen in action. On the screen, you can now see the Android Automotive operating system running on vSkipGen. Our solution fully leverages GPU acceleration capabilities provided by the server hardware platform. Thanks to that, even the most graphics-intensive high-resolution, high-FPS, multi-display user interfaces run smoothly on vSkipGen with the native speed. Some vendors are building their main IVI and cluster solutions using automotive-grade Linux. vSkipGen provides the same level of support and capabilities for these guest systems as it does for Android Automotive operating system virtual machines. Even better, you can implement and test interactions between different guest VMs over a variety of mechanisms, such as VirtIO networks, virtual sockets, or shared memory. Virtualized cluster solutions for automotive can be also developed on vSkipGen, benefiting not only from the native graphics performance, but also from the full support of virtualized automotive buses, such as VirtIO can. To replicate the virtual environment even more precisely, vSkipGen users can also interact with commercial and open-source simulation tools such as Carlo. In addition to its many features and capabilities, vSkipGen allows enterprise customers to efficiently share the computational power of the modern multi-core ARM64 servers between multiple developers and testers working in parallel. This significantly reduces the cost of ownership for big organizations and support the global effort to reduce the carbon footprint. vSkipGen Pro delivers a complete CDC development environment on a single Graviton instance. That allows OEMs to deploy their own virtual machines across Android Automotive operating system, AGL or Linux. The Enterprise Edition builds on top of Pro, offering cost savings by running multiple vSkipGen containers on one Graviton instance, enabling engineering teams to share resources. Both versions include support for integration with customer OEM-specific tools, for seal testing, and full CI/CD/CD workflows.
vSkipGen fosters and supports the usage of open industry standards and technologies, such as VirtIO itself, TDS, some IP, VSS, View Protocol, and many others. It serves as a robust platform for companies to prototype, evolve, evaluate, and cross-check new and emerging open software standards. In addition, vSkipGen is capable of integrating virtual ECUs from ecosystem partners and other vendors, whether originating from the AWS environment or from proprietary SIL setups. It enables seamless collaboration and interoperability across diverse toolchains and workflows, in alignment with the SOAFEE's initiative push for interoperable automotive platforms and cloud-native technologies. Panasonic Automotive's vSkipGen is available to interested customers via AWS Marketplace for evaluation or commercial use, subject to applicable licensing terms and end-user agreements. Aligned with our ongoing work to extend VirtIO-based virtualization into both Cockpit Domain Controller and ADAS solutions, vSkipGen empowers customers to develop, validate, and deploy next-gen cockpit and advanced driver assistant features entirely in the cloud. This approach accelerates the transition to AI-defined vehicles with a feature roadmap to support NPU-accelerated functions, paving the way for intelligent, cloud-native automotive systems. Thank you for your time and interest in how we are enabling the evolution towards the AI-defined software-driven vehicles.